Hello everyone, welcome to another learning session of Foundation of Programming at CodeMode, where you learn by practice. Currently you are learning about algorithm and flowchart, and in today's class we will learn about iteration control in flowchart. Before I start, don't forget to like this video and subscribe to our channel, especially if you are watching on YouTube. For complete course and practice, go to our platform my.codemode.us. Let's begin. So far, we have learned about two types of controls in the processing block. The first one was sequential processing and second was conditional processing. The third type is referred as iteration. An iteration is very useful when we want to repeat the same instruction or a set of instructions multiple times. And it is in real life it is very much possible. You will see a lot of scenarios where we iterate. For example, we have guests in our home and we want to serve the tea. If there are 10 guests, we are taking the tea, handing over the cup of tea to first guest, then from the tray take the second cup, give it to the second guest, take the third cup, give it to third guest, and so on. And as you can see, the two steps, taking the cup and taking the cup from the tray and handing it over to a guest, these two steps we are repeating it 10 times for 10 guests. Now we can do the same thing in sequential processing. We can write steps like take cup, give to guest 1. Then we can repeat this and say take cup and then give to guest 2 and so on. But then if today we are talking about 10 guests, maybe tomorrow we have 15 guests. In that case, it is very hard to write your flowchart or repeat the set of instructions unnecessarily. This is not efficient. That's why in flowchart or in algorithm, we have a way to repeat a set of instructions. And that's where iteration comes very handy. Again, you can look at this and there are a lot of examples like this. Another example I have written on the screen where you can see that in order to take a bath, we lather, we rinse, and we repeat until we are clean. So these two steps, we keep repeating unless we are really clean, and then we stop. Take another example you see on the screen. In the screen, we again, as like in any other flowchart, we have a start and we have an end, and then we have one step here, which is a diagram, which is a rectangle. So it's part of processing. This is a sequence, and we create a counter. Counter name is I, and we start with I equal to 1, and then we say if I is less than equal to 2. So this is a condition, and you can see it's a diamond, which is a second type of control in the processing block. So we check if I is less than 2, and if answer is yes, then we go and show the value of I, which is right now 1, and we show 1 here, and then go, and you can see this is an output because I use the print, and you can see it's in parallelogram. So we output I, whatever is the value of I, which is 1 right now, and then we increase the value of I by 1. Now in the case of computer programming, I equal to I plus 1 is a perfectly valid statement. Basically we are saying take the current value of I, add 1 to it, and whatever is the new value, assign it back to the new I. So if I is 1, we add 1 plus 1 becomes 2, and I becomes 2. In math, this type of statement is not valid. You cannot say I equal to I plus 1. But in programming, I equal to I plus 1 means first take the value of I, add 1, becomes 2, and assign new value of I. Now I will become 2 after this statement. And again, this is a processing, so it is in the rectangle. And after this is done, you go back, and this is where the loop part is. This is where the iteration is. As you can see, after this statement, I am going back again and again checking here. Is I less than equal to 2? And right now, if you remember, I is 2. So our answer is still yes, true. So it will again come here and print 2 this time because I is 2. And then go back and increase the value of I by 1. So I will become 3. And then again go back and check, is I less than equal to 2? Answer is no this time because I has become 3. Remember, we increased with 2 times, we increased the value of I. So now this condition is false, and that means it will exit and it will go and stop the program. So in a nutshell, this program or this algorithm starts with 1 and prints the value of a counter, which is I in this case, on the screen and increase by 1. So it will first time print 1, it will print 2, and then it will skip, it will come out, and these are the only 2 things. So basically somebody is trying to write a program, or somebody is writing a program or an algorithm to print 2 values 1 and 2 on the screen. I can, if I want to print 10 values, all I have to do is to change these 2 to 10. That means I'm saying keep printing and keep incrementing the value, do these 2 steps, print and increase the value till I is 10. And once I is more than 10, get out. That means it will print 1, 2 up to 10 and then skip and exit. So as you can see, the 2 steps here, two steps here, this step and this step are repeated based on a condition. The condition is controlling how many times this loop will continue. This iteration will continue. Loop and iteration are interchangeable words. Now the important part is this arrow that takes it back and makes it continue like this. This, as you can see, this forms a loop. Now anytime you write a loop or iteration, remember you need to exit the loop, otherwise you are gonna run into infinite loop. So as the word suggests, there are 2 types of iterations. One we call it finite. There are 2 types of iterations or loop. One is called infinite, which you don't write it, but you may accidentally write an infinite algorithm or logic. And second is finite. Infinite, we don't write it because your computer program, when you write it in your code, is gonna crash because it will take all the memory and processing power. Now we always write finite. We unintentionally or accidentally write finite when we fail to give an exit condition, and I'll talk about it in a minute. In the finite, there are 2 types of again loops. One we call it definite, and another is called indefinite. Now definite is when you know number of iterations upfront. I have 10 guests, so I know that it will be iteration of 10. The loop you saw here, this is an finite loop because we know that we will print 2 values, 1 and 2. If I give I less than equal to 10, then I know I'm going to print it 10 values. So that number of iterations is controlled by a condition, and this is a finite loop. We have a counter usually in the definite loop. In the definite loop, we have a condition and we also know number of iterations upfront. And in real life, you will see when we say we have 10 guests, we have 20 guests, I'm going to run 5 kilometers. All of that, is a type of definite loop. You know upfront the exact number of iterations. Whereas the indefinite loop is still controlled by condition, but in this case, you continue to execute the loop, you continue to repeat the steps until the condition is satisfied. So take an example. Say keep playing till it is dark. Now in the winter, dark could be at maybe 5 o'clock. In the summer, dark could be at 8 o'clock. So how many hours will you play? It depends on whether it's dark or not. So the condition, whether sun has set or not, is driving number of hours you will play. And that is what we call it as indefinite. It's a condition, still a condition is driving it, but you don't know number of times the loop will occur or number of iterations it will occur. It is driven based on a condition, and number of iterations is not known upfront. That's all in today's class. I would request you to practice, because loop can be a little bit tricky unless you write your instructions, unless you write the flow chart. You will not be able to get perfection. Also, if you have any question, go ahead and post it in the community on my.codemode.us. Take time to solve the quiz. That's all again. I'll see you all in the next class. Keep learning.